All right. Well, good morning, everybody. I think we are live at this moment, and if there was a delay issue, I'm going to stall for a few minutes, like I usually do, just to give everybody an opportunity to log in and get started with the lesson. So, just as a quick recap, we last week we started Unit 7, and we were learning how to balance equations, and then the next day we started talking about the different reaction types. So there's 5 reaction types. All reactions are going to have to be balanced, and we go through the necessary steps to get all that done. So just as a quick recap, let's take a look at the list that we made for the tips of how to balance. So tip number 1, if you're trying to balance these reactions and you get stuck, the very first thing you should do is just stop, start over, put a 2 out front. You're essentially doubling everything that's in there, and most of the time that works itself out. The second tip was to balance the polyatomics as one thing. So if you have a phosphate on both sides, balance the phosphates instead of balancing phosphorus and oxygen separate. Now, that was just one example. You have 25 polyatomics that you're responsible for, so you're going to need to use that skill for the polyatomics. The next tip, tip number 3, was occasionally it helps you balance a little faster if you rewrite water as HOH. Doesn't always work. It's not something that you can truly rely on 100%, but if you get stuck, this might help you get out of that issue. And the last thing, if you have something that's all alone, all by itself, usually a metal usually a metal, do that last. That way, the only thing that you're affecting is if you put a coefficient in front of that metal. That's the only thing you're changing. So those are the tips, and there's 4 of them, and I kept mine, so we will be using them again and again. Got a couple people checking in. What's going on, guys? It looks like we have 4 people watching so far, and at the moment we have had, 8 people sign in for attendance today. So there may be a couple people who just logged into the Google Classroom, said they were here, and then went back to bed. It's entirely possible, but we're up to 4 people. Okay, yep, 3 people are saying hi. Now, for the next thing that we talked about, and after we get done this, we'll get right into the worksheet that I gave you last week, and we'll start doing a couple more examples. This was the 5 reaction types that we covered. All right, so the first one that we talked about was combination. Very easy to distinguish combination reactions is when you have 2 reactants and only 1 product. The next one was a combustion. That's if you have anything reacting with O2. O2 must be a reactant. This is a combustion reaction. We'll get into more details of each of these later today. The next one was a decomposition. This is just the opposite of a combination, when you have 1 reactant breaking down to 2 or more products. And finally, we had a single and a double replacement reaction. The single is when you have a metal plus an ionic compound, and a double is when you have 2 ionic compounds reacting together. So that's that. Let's go to the worksheet that we started last week, and whatever day that was. I think it was Friday. Anyway, we did the first couple. See if I can zoom in here, make it a little easier to read. All right. We did these first couple. I'm not going to balance these 6 because we already did them, but I might balance a couple after that. All right. So let's go down to let's just make it an even number 10. All right. So number 10 should be a little easier. I'm going to balance this right here, and I'm going to do my best to think out loud so you can kind of see where we're going with this. All right, let's do this here. All right, so number 10, I have 1 potassium, 1 potassium. Potassium's already good. I have 1 hydroxide. I do not have any hydroxides over here, but I do have water. So I'm going to rewrite that water as HOH, and that should help get this figured out. 1 hydroxide, 1 hydroxide. Good. Then I have 1 H and 1 H. 1 Br, 1 Br. This one's already balanced. All right, so that one was easy. Let's do number 11. Oh, first, number 10. What kind of reaction is this? You got to go through those things that we just talked about, right? Looks like I have an ionic compound and an ionic compound. So this must be a double. Okay, and we're going to go over that in greater detail, hopefully today. All right, number 11. that is also pretty easy to balance. I'm going to do sodium's last because it's by itself. Oxygen, I got 2 here. I only got 1 here. So I'm going to put a 2 there. All right, oxygens are balanced. Now, if you look at it, it looks like I have 4 sodiums on the right. In other words, after the reaction's over, I have 4 sodiums. So I need to put a 4 here. Done. Now, what kind of reaction is this? What do you guys think? I have a metal and an oxygen gas, or just oxygen as a reactant. So that must be a combustion. But if you look carefully, this also satisfies the requirements for it to be a combo. 2 reactants, 1 product. So I'm going to call this a combo as well. That can be a combustion and a combo. That's the only time where something like this could happen, okay, where you're going to have 2 possible answers. It's when it's a combo and a combustion. Not all combos are combustions. Not all combustions are combos, and you'll see that. Next, Johnson, does that make sense? I see your answer there. I hope that makes a little bit more sense. All right, number 12. It looks like I have 1 aluminum and 2 aluminums over here. Okay, so I'm just going to start off by putting a 2. All right. Then, now it looks like I have 6 hydroxides, 2 times 3. Over here, I have a water. So you see how rewriting this as HOH might be helpful? So I got 6 hydroxides. I'm going to put a 6 over here. And that gives me 6 hydrogens. Okay. Well, I only have 2 on this side, so I'm going to put a 3. Gives me that 6. Then I got 3 carbonates. I got 3 carbonates right away. So that one's done. 2, 3, 1, 6. Now, what kind of reaction is this? This looks to me like we need to follow those 5 types here. We got an ionic compound and an ionic compound. This is actually an acid, okay? And we talked about how acids start with H's. So they classify, at least in this scenario, as an ionic compound. It's definitely not molecular. All right, so ionic and ionic, that means it's a double. So on the right-hand side, you're going to be just labeling that as a double. Let's do a couple more, and then we'll get into more details of each. Number 13, this is going to be, right off the bat, a single. Not a single. I'm speaking out of turn here. It's going to be a combo. You got 2 reactants and 1 product. So this is going to be a combo right off the bat. Now, you can see how this combo is not a combustion because there's no O2. Anyway, let's balance this. It looks like I got 2 aluminums here, but only 1 there. And I'm going to run into an issue. Okay. I got 8 sulfurs, and it looks like 3 sulfurs. Now, I can't get each of these, like I can't get that to be a 3, and I can't get this to be an 8. So what I'm going to do is get them both to a common multiple. Now, to do that, I just 3 and an 8. Now they're both 24. So now I got, looks like 16 aluminums. So I got to put a 16 here. Now, don't forget your last step of balancing any equations. You're going to reduce these if you can. So 16, 3, and 8, you can't reduce that. We're good the way it is. Now, the reason why I brought that up just now is because these numbers seem a little higher. 16, it might be the first time we've seen something that high. And there was a chance that we might have overbalanced it, so we would have to reduce it as our last step. All right, 14 and 15 are the last 2 we'll do before we move on. 14, it looks like that's also another combo. 2 become 1, okay? I have 3 cesiums, 2 nitrogen. So let's do nitrogen first. I'm going to save cesium to the end because that's truly by itself. Nitrogen is by itself, but it comes in a pair. That 2 might complicate things. So let's do nitrogen first. Put a 2 there. My nitrogens are balanced, and now I got to put a 6 here for cesium. Done. You guys following along? Is this making sense? Give me some feedback here that you guys are good with these couple examples we've just done. Last one. This is also a combo. 2 become 1. Follow the same pattern, right? Let's do magnesium last. It looks like chlorine and chlorine already match. Magnesium and magnesium, good. So this one's balanced as it is. It would just be 1, 1, 1 for the answer. Okay, so that's that for, okay. A couple people are saying that we're good and we're making sense, so I'm going to leave it at that. Now, let's go over some more details for each of these 5. Okay, remember these 5. You got to have these 5. Let's put this paper here. Okay, we'll zoom back out. Sorry about the camera movements. Just trying to get everything done at the same time. You know, this is not a professional shoot here. Anyway, 5 types: combo, combustion, decomp, single, and double. Those are the 5. Now, we're going to go through each of these 5 with a couple of more details. And as these questions progress in difficulty, I'm going to start taking away information. So you're going to have less info, but you're going to know more about each type. So you'll be able to still do the same work with less information. When I say less info, I mean I'm going to be taking some of the products away. Okay? So far up until now, you've had both the reactants and the products. I'm going to take away the products, so you got less information to make this determination, but you'll have more information about each of these types to do that. Okay, so I hope that's good. All right, let's see. Now we're down to 2 people. This is slowly slipping away to nobody. Okay, where'd everybody go? At least I got the same amount of likes as I do viewers. Okay, so let's go to a blank piece of paper. Okay, and let's talk about combos. Let's talk about combos first. Okay, so a combo reaction, we said, is when 2 become 1, right? Now, a couple more details about that. It's, for us, let's say 99 times out of 100, it's going to be a metal plus a diatomic. Remember your diatomics? There were 7 of them. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. I think I got them all. All right, so if you see that, no products mentioned here at all. If you see that, you know right away it's a combo. But how do you figure out the product? You're just going to do the crisscross. Now, you got to remember that from last unit, Unit 5. So this is all the info you need, okay? If I give you a metal plus a diatomic, to get the product, you just do the crisscross. It's that easy, all right? So let's do a couple. Let's say I had sodium plus fluorine. Okay? So you have to do the crisscross between sodium and fluoride. You got to go to the periodic table where all the charges are that we've talked about in the past, and you got to realize that sodium is a +1, fluorine is a -1. So you do the crisscross. All right? Now, here's where a lot of people are going to get into trouble. You're going to get somebody who, for whatever reason, is ignoring this step of doing the crisscross. And they're going to take this 2. They know that fluorine comes in a pair when it's alone. But for whatever reason, they get stuck in that mindset. Do not do this. This is wrong. Okay? This is an example of what not to do. They see this 2 here, and they assume that there must be a 2 after this fluorine. Well, if I put a 2 here, now the crisscross is wrong. This is not the correct formula for sodium fluoride, and it's not balanced. It's not neutral. So don't, just because there's a 2 here, put a 2 here. Don't do that. You got the 2 here for a reason. That's a diatomic. There's nothing here because of the crisscross. You fix that by balancing the equation. Okay? So you do sodium last since it's by itself. Fix the fluorines. And then fix your sodiums. That is the balanced equation between sodium and fluoride. Okay? Don't fall for the trap of feeling like you need to put a 2 there just because there was 1 at the beginning. You fix all that nonsense by balancing the equation. Let's do another one. Let's say I had barium plus chlorine. Do the crisscross. Barium should be a +2. Chlorine's a -1. So you should get this. Now, let's go back. Let's try and analyze this a little further. This 2 is here because of the diatomic. This 2 is here because of the crisscross. These 2 2s have nothing to do with each other, and it's just a coincidence. This is something that we would talk about over and over if we were in class together. I would ask you, each one we do, why is this 2 here? And then you guys would say, because of the diatomic. And then I would ask you why this 2 is here, and you would say because of the crisscross. Do they have anything to do with each other? No. Coincidence. That's it. That's all it is. Now, this one's actually pretty easy to balance. 1 barium, 2 chlorines, 2 chlorines. You're done. So that's a combo, okay? Now, there are times when earlier I mentioned that some combos can be called a combustion. So let's do, I'm just making this up. I got a metal plus a diatomic. In this case, potassium plus O2. So right away, we know it's a metal and a diatomic, so therefore it's a combination. But this one can also be a combo, or a combustion rather, because of the O2. So you would get 2 correct answers out of this, but you would get the same product, whatever type you go with in this case. You got to do the crisscross. Potassium's a +1, oxygen's a -2, so you would get K2O. And then you balance. Do potassium last, because it's by itself. I got to put a 2 here to fix my oxygens, and then a 4 here for potassium. So we get 4, 1, 2. But this one's also a combustion because of the O2. I hope that's sticking with you guys. So those are combos, okay? Let's do combustion, okay? What I'm going to do after we go over these 5 types is I'm going to find a worksheet online, and I'll put that on the Google Classroom so you can practice very simple predicting products, and I'll go over that again tomorrow, okay? Kind of like what we have been doing the past couple days. Combustions are always something, whatever that is, doesn't necessarily matter at the moment, plus O2. So when you see that, you should be thinking combustion right away. That's info I gave you yesterday. Now, there are technically 2 kinds of combustion. There's when you have a metal plus O2. When you do that, you should get the crisscross for the product. And that is just like what we went over a moment ago, okay? So this one can also be called AKA combo. You already know how to do this because we just talked about that a minute ago, okay? Now, the only thing left is to talk about the other kind of combustion, all right? That's a review right here, okay? We just talked about that. That's up here somewhere. Now, this new stuff over here, okay, I'm going to cover up that old stuff so you don't fall for this. This is when we have something called a hydrocarbon, which I'll define in a moment, plus O2. What you get is every time, there's no guess here, okay? You do not have to figure out what the products are. This is more of a rule. If you have a hydrocarbon, which I'll define in a moment, you always get the same 2 products, CO2 and H2O. All right, now what's a hydrocarbon? A hydrocarbon is anything that is made up of only hydrogens and carbons. Hydrocarbon, all right? Hydrogens and carbons. Give me some feedback in the chat, you guys. Let me make sure that you're staying with me. If you have any questions, you should be asking them too, okay? Because as I'm going, if I don't get any questions, I'm just going to keep going. Anyway, hydrocarbon is only hydrogens and carbons. Let's do 2 examples. All right, so 1, CH4. That's the formula for natural gas or methane. This is what comes out of your, if you have a gas stove top in your kitchen, this is the gas that is being burnt. It's also used to run like water heaters and things like that in your house. It's the same gas that we would use in the Bunsen burners in the classroom. All right, a couple people are telling me that we're good, so I'm going to keep going. Now, if I take CH4, natural gas or methane, and I react it with O2, if this is all I give you, you should still be able to determine that it is a combustion reaction, okay? Now, with that, since it's combustion because of the O2, and it's a hydrocarbon, there's no thinking needed. You just do CO2 and H2O. All right? That's it. It's a rule. Now you have to balance it. So I'm going to do oxygen last. It's the one that's closest to being by itself, so which means I got to do C and H. I'm going to do H first, just because it looks like carbons are already balanced. I might have to go back and fix that, but we'll see. 1 and 1 for the carbon. Hydrogens, I got 4 here, so that means I got to put a 2 there in front of that H. Kind of crammed it in there. That gives me 2 oxygens here, plus another 2, so that's 4 altogether on the right. That means I need 4 oxygens on the left, so I'll just put a 2 there. Balanced. Okay. It looks like the same people are watching these videos each and every day. And guys, I appreciate that. I really do. You'd probably be the same ones that are paying attention in class anyway. Let's be honest with ourselves. Okay, next, let's do another one with a different hydrocarbon. This time I'm going to do a thing called propane. This is the same stuff you would use for your grill outside with the big gas containers. So that is C3H8 plus O2. So you see the O2, and you should instantly be thinking, okay, this is a combustion reaction, and that's a hydrocarbon, so I don't have to think. This is more of a rule. I'm going to get CO2 and H2O. There's no thinking so far. It's either doing the crisscross, or I got my two products that I know for a fact are going to work. So now you got to balance. This one might take a bit more of an effort because of this carbon here. So I'm going to do oxygen last, just like I did before. I got 3 carbons. Let's put a 3 there. I got 8 hydrogens, so let's put a 4 here. Carbons and hydrogens are balanced. Let's check our oxygens. On the right, I have 6 plus the 4, so that gives me 10. 10 oxygens on the right. So to get 10 over here, I just put a 5. Okay? So that is combo and combustion. Now let's do decomposition. Those are the easier ones. Combo and combustion are definitely the easier ones, only because of the straightforwardness of it all. All right, iced tea for breakfast. All right. So let's do decomposition. Decompositions are fairly tricky, but I'm going to give you the easier ones. So let's do decoms. Okay? This is when you have one reactant and it becomes 2 products. It's the opposite of a combo, okay? Very straightforward ones are going to be the complete, like I said, opposite of combos. So it's going to be probably an ionic compound breaking down into their 2 pieces. Now that sounds weird, but watch. Let's say I had sodium chloride. What's sodium chloride made up of? Well, sodium and chlorine. So I do sodium and chlorine. Now, why is that 2 here? You should be thinking to yourself, it's a diatomic. I got to put a 2 here. Why did I not put a 2 here? Because that's an ionic compound, and the crisscross told me not to. So you have to leave that 2 out. If there was a 2 here, it would be simply a coincidence. Does this all sound familiar based on what we talked about with the combos? Remember that speech I was giving you? Anyway, that's all a decomp is going to be. That's a very, very simple decomposition reaction. Others we're not quite ready for, but I can give you an example so you can see where this might be going. Let's say I do barium carbonate. Okay, now you see how right away this is starting to get messy because I got a polyatomic. It's an ionic compound, just like sodium chloride is, and that's going to break down into 2 pieces. Well, I'm going to get barium oxide and carbon dioxide. How you know that is not something that we can really go over right now, but what I need to let you know is that some of these decompositions are very straightforward. You just break them down into their pieces. So sodium chloride would be sodium and chlorine. Iron 2 oxide would be iron and oxygen. I think you get that. The more difficult ones are going to involve the polyatomics, and that's when you're going to get an ionic compound and something else. This comes with experience, and this is a guess and check method. We'll be going over that tomorrow, okay? But right now, what I want you to do is just take the basics, and you're just stepping it up a little bit, okay? Now let's do singles. Okay? A single replacement reaction, we said earlier, is an ionic compound. Actually, we said a metal plus an ionic compound. Okay? M stands for metal, IC, ionic compound. I didn't tell you what the products were going to be. What you're always going to get is a different metal and a different ionic compound. I hope you guys are seeing my shorthand here. So metal plus ionic compound is going to make a different metal and a different ionic compound. Now, there's also another side note here. What I'm going to say is that the metals switch That's the whole deal here with singles, okay? So you got a metal here, but in every ionic compound, there's also a metal. So the metals are going to switch places. That's why we end up with a different metal by itself and a different ionic compound, because the two metals that were here end up switching places, okay? So let's do an example. Let's do a straightforward one. Let's say barium and magnesium sulfide. I got my metal and ionic compound. And I'm telling you that the metals are going to switch. So let's look at it this way. You see where magnesium is with sulfur? Well, after the reaction's over, magnesium is going to be by himself. Okay? That leaves barium and sulfur to get together and make a compound. So you got to do the crisscross now with barium and sulfur. Turns out BAS reduced. That's a simple one, okay? We can do all kinds of goofy stuff. Let's say we got, I'll show you a hard one, okay? Let's just go right there. Let's say I got calcium and iron 3 phosphate. Okay? Calcium and iron 3 phosphate. Metal plus your ionic compound. Metals are going to switch places. Okay? So when that happens, iron is now going to be by himself. Just because it's iron 3 over here doesn't really matter anything over here. Okay? Then calcium and phosphate are going to get together. So you got to do the crisscross there between those two. Calcium is a +2. Phosphate is a -3. So when you do the crisscross, you should get something that looks like this. Okay? Now you have to go back and balance it. I didn't do that one up here because it's already balanced. I may have glossed over that fact, but it's already balanced. Next question. This one is not balanced the way it comes out, so you have to do that. So I'm going to do iron last. I could do calcium last, but it looks like I have 3 over here, where iron is already 1 and 1. Okay, so I'm going to do iron last. Let's do calcium first. Actually, let's do phosphate first. So I got 2 phosphates here. This is one of your tricks to do the polyatomics as a group. Put a 2, right? And then my calciums, I got 3. So put a 3 there. Last thing we said was iron. 2 irons. Put a 2. That's your singles, okay? Here's a story that one of my professors gave me when I was learning this to help me remember this, all right? Think of molecular or ionic compounds, rather, as a couple, okay? And you have this person over here by himself, okay? Well, iron and phosphate go to a party. Calcium is also at the party. Well, this is one of those destructive, toxic relationships that we all have heard about, okay? They want to break up, but it's not something that they're willing to do right away. They're kind of just looking for an excuse. They're so comfortable with each other. They've just been this way for so long. They're stuck in the relationship. When they go to this party, calcium's also there. Well, phosphate sees calcium across the room and ends up leaving with somebody else, and therefore iron is now single. No matter what, there's always somebody who's single. Before the reaction, calcium was single, but the metals switch, so now iron is single. That's just how I was taught. It seems to work. All right, let's do doubles, and we'll wrap up the lesson. And I'll give you a tip or two before I close out the video. Okay? Doubles, I'll be honest with you, are not very different than singles. If you can wrap your head around singles and how the metals are switching places, you could do doubles as well. We said earlier that it's 2 ionic compounds. All right? I never gave you the products. Turns out what you're going to end up getting is 2 brand new, different ionic compounds. The mechanism of this reaction is the same as singles. So the metals switch. Got to spell switch right. So the metals are going to switch places. So there should be a metal here in this ionic compound. Should be a metal here in this ionic compound. Well, if they switch places, that makes sense to get 2 brand new ionic compounds. Okay? All right, let me know in the chat if you guys are with me, if you're good, if you have any questions, what have you. Let's do an example or two. All right, so sodium chloride plus potassium fluoride. 2 ionic compounds. I got my metal and sodium and potassium. They're going to switch places. So sodium used to be with chlorine, but now sodium is going to be with fluorine. Do the crisscross, I get NaF. Potassium used to be with fluorine, but now potassium is going to be with chlorine. Crisscross, done. All right, you guys are good. You guys are with me. So that one's already balanced. That's a double. Metals are just switching places. I did the crisscross for each ionic compound, and then you got to balance the whole thing. Turns out this one's already balanced. So let's try one, okay? Actually, let's step it up in difficulty in the examples. Let's say I got iron 3 sulfate, okay? Plus, let's throw a weird one at you. Ammonium acetate. Okay? Now, this is almost a trick, but it's really not. In singles and doubles, I was saying that metals switch places. But in this one here, there is actually no real metal. So what I should be saying is not metals switch places, but cations switch places. You remember that word? Positive ion. So the positive ion in this one is ammonium. So ammonium is going to swap and switch places with iron. Okay? So iron used to be with sulfate. Keep in mind this is iron 3. So iron 3 is now going to be with acetate. So I got to do the crisscross. I'll do it down here so it all fits. Iron 3 acetate should look like this. Okay? Ammonium and sulfate. I got to do the crisscross there. Ammonium is a +1. And sulfate is a -2. So there you go. The last step is going to balance this. You don't have anything by himself, so you really just pick one, okay, and you go for it. Let's do iron first. Let's say I got 2 irons here and only 1 here. So I'm going to put a 2. Irons are good. Now that leads me to look at the acetate. Looks like I got 6 acetates, right? 2 times 3. So I'm going to put a 6 up here to give me 6 acetates. That also gives me 6 ammoniums. So down here I got 2 already. I'm going to put a 3 here. Gives me 3 times 2 is 6. Looks like now I have 3 sulfates on the right. But it turns out I also only have 3 on the left. So this is already balanced as is. The answer is 1, 6, 2, 3. 1, 6, 2, 3. And you can't reduce that, so this one's already good. All right, let's switch cameras here. So that's pretty much the day's lesson, okay? All I really did was review and give you some more details for each of the 5 types, okay? So hopefully you're updating this this list that you got, and you got this thing here. Let's show you that. So remember this at the beginning, okay, where I gave you some very, very basic and limited information, but then we went through and gave you more information. So if you're taking notes with this, you're just updating these notes from last time I talked to you, okay? Now, I'm going to go online, and I'm going to find a worksheet where it's on the easier side, of course, because we just started this, but I want you to start predicting products, okay? So now you have to be able to, in this order, tell me what kind it is, predict the products based on all the info from today, and then balance. Balance is always the last thing. So identify, predict, balance. Identify, predict, balance in that order, okay? So I'm going to put this worksheet up on the Google Classroom attached to this announcement for the link, and we'll start class tomorrow by going over that. Now, the way this week is looking, let's talk about the schedule. We have class all week except for Friday, and then it's spring break next week. So we're going to have to come to a naturally good pause or a period in the lesson where we could just kind of take a break, and it'll make sense to pick it up from there. So I'm going to have to figure that out. And also Wednesdays have been dedicated to nothing new, more of a catch-up day. So we'll probably do a Q&A live stream that morning, and then Thursday might be the last chance I have to squeeze anything new in before the long break. So we'll figure that out. So long story short, new stuff today, of course, new stuff tomorrow, a breather day on Wednesday where I'll still talk to you. Thursday will be new stuff depending on where we end up tomorrow. I'll figure that part out, okay? The break is Friday and then all of next week. So if you go on the school's website and find the calendar for 19 to 20, it's in there. I think it's 10 days, including weekend. So, yeah, it's a good amount of time. So we have to take this break the same way we would have if we were in school. Don't, forget about me. Don't forget about BTHS, okay? We still have work to do once we get back from that break. But, yeah, we're off on Friday. We're off all next week. We come back the following Monday, I believe. So that's that. All right, go check Google Classroom in the next couple of minutes. I'm going to log out of this live stream and get started my honors class. I got to meet up with them at 10, okay? So I appreciate you guys checking in, and go to the Google Classroom. We will start tomorrow's class by going over today's worksheet. All right, thanks, guys. I'll talk to you tomorrow.